Hi, this is Miss Oliva, and I'm going to be going over solving polynomial and rational inequalities. This is from 2.7. And this is the last section from chapter 2. Okay. So first is just looking on a graph and being able to identify where the function is less than or greater than 0. So keep in mind that when it says f of x, again, that means y, really. So when it's asking where f of x is less than 0, it really means where are the y's less than 0. So first, let's keep in mind that this, the x-axis, is where y equals 0. So if they're asking me to be less than that, I'm going to be looking at this section and this section. And now I'm explaining where that's happening. And whenever you're explaining where something's happening on the graph, you're always explaining that with the x's. So even though I'm looking where the y's are less than 0, when I explain these sections, I'm talking in terms of x. Same thing when you're describing if something's increasing and decreasing. You would say, oh, it's increasing here because it's going up, but now I'm going to explain it just using the x's. So how do I explain this section? Well, there's an arrow, so that means it's going to keep going left forever. So I'm coming from negative infinity to -2. I'm not going to include -2 because it didn't say less than or equal to. So I need to put a parenthesis. But then there's another section that is less than 0. And that's the section from 0 to 4. Okay. Next one's asking me where it's less than or equal to 0. So that's going to be the exact same answer, except when I do get to this -2, I will include it. And same thing with the 0 and the 4, because I do want to include where it equals 0, which are these points. Okay. Now greater than 0 is going to be above the line. So that would be these two sections. So, and again, no equal to, so I don't want to include any of these zeros. So -2 to 0 is one section where it's above, and 4 going on forever. And then same thing, it's now just asking for it to be greater than or equal. So now I will include all of those points. And remember, we never use a bracket with infinity. Okay, same exact thing, but now just a little bit more complicated. So this would just be a polynomial graph. And this, since you see it has some asymptotes, would be a rational function. So it must be some kind of a fraction. So again, though, where is it less than 0? I'm again focusing on this line where y equals 0 and trying to see where would it be less than. So that's just this point, and it's just going between, because again, I'm just talking about x's, between the 0 and this asymptote that looks like it's at 1. So that's it. That's the only section where the graph is below y equals 0. So now, if they want less than or equal to, I'm going to include the 0 because that's a point where it's equal to 0, but I'm not going to include the 1 because that's an asymptote. It's not equal to that. So you got to be a little careful. Don't just make everything a bracket. Make sure you look at the graph. Okay, same question, but greater than, I'm looking at this and this. These are the two sections of the graph that are above the line y equals 0. So this section is coming from the left, so from -infinity to 0. And the other one starts just at that asymptote. So that asymptote looks like it's at 1, and it goes to the right forever. Including the 0, again, makes me change this to a bracket, but not the 1, because it doesn't equal 0 there. That's an asymptote. Okay, so just be careful with your parentheses and your brackets. But overall, make sure you're thinking less than 0 means under the x-axis, greater than above. Okay. The next part of this section is actually solving inequalities. So if you have an inequality equation, how do we solve it? And it seems like we would just solve this just like an equal. So we would just move the 4, the 9, and start solving. But it's a little more complicated than that. So I actually gave you steps. So step 1 is to get it equal to 0. And what I mean by that is just get everything on one side. So that's already happened in number 1. Then either factor, which we're going to do here, or you might need to combine fractions. That's going to happen in this one because I'm going to need to bring that 2 over and then I'm going to have to combine those. So we'll get there in a minute. But for now, get everything on one side and then at least try to factor. This is a difference of squares, meaning that's a square term, and so is that, because 2 times 2 is 4. So I can factor this. Again, I think some of you might be realizing that you definitely need to review factoring a little bit. So please do that if you can, and if you need me to send you maybe a website to practice some factoring or some worksheets on it, let me know. If we set each one of these equal to 0 and solved, we would get negative 2/3 and 2/3. But here's the trick. We are not done. Those are not our answers. That's just going to help us get our answers. So set equal to 0, we did that. Factor, we did that. Find the zeros, we did that. Or domain restrictions, that's going to come in when we have a fraction. But now we set up a number line. So those zeros or domain restrictions that we find are what we're going to put on this number line to split it up into sections. So I'm just putting 2/3 or negative 2/3 and positive 2/3 on here so that now I have 1, 2, 3 different sections to look at to figure out which one or ones do I like. And I'm going to like the ones that make it greater than or equal to 0. So basically positive. So how do you find that out? You pick a number in each section and you test it out. So a number in this section, I could try -5, -25. I'm going to be kind of lazy and try the smallest one I kind of think of, and that's -1. So you can plug it back into the beginning or into this factored form. And I don't really care what the answer is. I just care, is that answer going to be negative or positive? So if I plug, I'm going to kind of rewrite this here. If I plug -1 into this, I would get a negative answer. And if I plug it into here, I would also get a negative. So a negative times a negative means this whole section, so from negative infinity to negative 2/3 is going to be positive. Now I test in the middle here. So the easiest thing between a negative and a positive to test is 0. So if I plug 0 in here, I would get a positive. 0 in here, I would get a negative. So negative. If it's confusing you that I'm just kind of talking in terms of negatives and positives, then plug it in and find out the actual number. I can just kind of take a shortcut because I know that all I really care about is that is it going to be positive or negative? So I don't really have to go through every single number if I know plugging this in would make this positive, this negative, and a positive times a negative is a negative. So now I'm going to plug in 1. That would make this positive. I'm just quickly saying 3 times 1 plus 2 would definitely be a positive. But put it in here. 3 times 1 minus 2 would also be a positive. So again, I have a positive. Now, since this question was asking me about being greater than or equal to 2, I'm going to go ahead and put solid circles here to remind myself that I do want to include those numbers in my answer. So which of these 3 sections made the function greater than or equal to 0? Well, this first one, which is negative infinity to negative 2/3, bracket. and the last section, which is 2/3 to infinity. Okay, so there's a lot of work that goes into these. So it's going to take a little while to get the hang of it. So I'm going to do a few of them, and then you definitely should try the entire homework and see if you're getting the hang of it. So for this one, there's a decent amount of work to do before I can even get everything on one side. So I'm going to distribute this 3, which gives me 3x plus 9. And then I'm going to move those to the other side by subtracting them. I apologize if I go a little fast sometime. If I'm going fast or not explaining something completely, it's because I do know that this is something you should have come into pre-calculus with. So it's up to you to kind of reach out and say, I'm not really okay with this. Can you go over it more? Or you can text me. Some people have started texting me homework problems and just saying help, and I'll send them some help. Or you can come see me in my office hours. So lots of options, but you need to reach out and make that happen, because I'm going to focus mostly on the newer stuff and kind of skip over, like, you should know how to move stuff to one side without me showing it step by step. So here we are. I now need to factor. This is the type of factoring I went over in the last video. So if you need to see it again, the AC method, because there's a number out front, I multiply the 2 and the -9 together first. Then I try to find factors of that add up to the middle number. So if I did a +6 and a -3, that would multiply to -18, but also add to 3. So now I use those two to rewrite that middle term. So the 2x squared stays, but now I'm going to say plus 6x minus 3x, and then the -9 also stays. Now I do factoring by grouping, which means I take out as much as I can from these two groups. 2x can come out of both of these. 3 can come out of these, but then I can already tell that my parentheses are going to have negatives. I want the two parentheses to match. So instead of taking out a 3, I'm going to take out a -3, and that would do it. Now that both of them have the x plus 3, I take x plus 3 out, and I'm left with 2x minus 3. So all of that was to get to here, to now set each of those equal to 0 and find my zeros. So here I subtract 3, here I add 3 and divide by 2. So my two zeros are -3 and 3/2, which is like 1.5. So I have 3 different sections to test. I'm going to test them by plugging in numbers into these two and seeing if it would give me positives or negatives. I'm looking for my final answer to be, where am I less than 0? So not equal to. So I'm going to remind myself of that and put open circles here, because no matter what, I'm not going to include those two numbers, because those numbers are where it is equal to 0. So if I test -4, so I'll show you the work here one time so you can kind of see what I'm doing. So when I say test -4, it means I go to this and I see what happens when I plug in -4. But I don't always go all the way. -4 plus 3, I just know right away that's going to be a negative because the 4 is bigger. This gives me -8 minus 3. So I know that's going to be negative, because a negative minus something is going to still be negative. So negative times negative means this entire section is going to be positive. So this is what I'm doing kind of in my head. If you need to show all the work, show all the work. But that's what you're doing, is you're plugging in any number in this section, seeing if the final answer is positive or negative. So now I'm going to plug in 0, which is always easier. 0 plus 3 is obviously positive. 0 minus 3 is negative. Positive times negative means that section's negative. Yes, most of the time they alternate, but not every single time. So don't do this and get a positive and then say, this must be negative and this must be positive. Because yes, that works a lot, but not always. Final section, I'm going to plug in 2. Be careful. If you plugged in 1, do you see that that would really still be in here? So you'd get confused. So make sure you're really picking something to the right of 3/2. So I'm going to think of 2. 2 plus 3 is positive. This would be positive. So positive. Go back to the problem to remember, what am I even looking for? I'm looking for where it's less than 0. So that would mean this middle section. So -3 to 3/2, making sure I use parentheses because I don't want to include where it was equal to 0. Okay, so that's how you do it if it was just kind of a standard polynomial. Get everything to one side, factor, put the zeros on here and test the different sections. When you have a fraction, it's going to be very similar, except we're going to put the zeros, which come from the top, and also any domain restrictions, which come from the bottom, on our number line. So it's actually less work for this one, because I can kind of just do that in my head. I know that 3 would be the 0 here, and -6 would be the one here. So if you don't know how I did that in my head, I'm just saying, how would I solve this? So I would add the x and get 3, but I could just do that in my head. Also, you're just kind of saying, what would make this 0? What would make the bottom 0 if x was -6? So I'm plugging these in. I do need to plug them in the top and bottom, but again, I'm mostly concerned with, is that going to make things positive or negative? So plugging in -6 actually makes the top positive, so be careful, because 3 minus -6 is like 3 plus 6. So that would be positive, and oops, I need to plug in something to the left, sorry. So I'm going to pick -7. Still, it would make the top positive, but -7 would make the bottom negative. So positive divided by negative is a negative. In between here, my favorite, I'm going to pick 0. Positive, positive, good. And if I picked 4, that would make the top negative, bottom positive. So we want to include 0, but be careful in this one. Including where it equals 0 really only affects the 3, because this -6 is a domain restriction. It came from the bottom, which means we never want to include it. So with the fractions, there's an extra thing to be careful of, that even if you have the greater than or equal to part, that really only affects numbers that came from the top of your fraction, never the ones that came from the bottom. So I want to be greater than or equal to 0, so that's my middle section, but it will be a parenthesis with the -6 and a bracket with the 3. So way less work for this one, but you just got to be careful you understand how I decided to make those open or closed circles. Okay, last one, another fraction. The one that looked like this was very easy a moment ago, but the problem with this one is we don't have the 0 there. We still need to have a 0 on the other side. Otherwise, how can I set things equal to 0? So I need to move that 2 over, which will be a little bit of a pain, because now I don't have one nice pretty fraction like I did a second ago. So I'm going to need to combine these two fractions, which means get a common denominator. Luckily, this 2 really just has a 1 on the bottom, so I can multiply by whatever I want. So I'm going to multiply by the x plus 4 to get that common denominator. So this is still just here for now, minus, distribute this, that's 2x plus 8 over x plus 4. The whole beauty of that is now that I have a common denominator, I can actually do what it says on top, so I can subtract those things. But just be careful. If you're subtracting two fractions and there's more than one thing up here, make sure that negative goes to both of them. So I'm really thinking 5 minus 8 and negative x minus 2x. And then on the bottom, it just stays. You don't actually add the bottom. You need the bottom of the fractions to match common denominator, but then it just stays the same. So now I can set the top and bottom equal to 0 and solve. So I guess I'm going to show all my steps for this one. So I'm going to add 3 and divide by negative 3. And then x plus 4 would equal 0 when x is negative 4. So I'm going to my number line. I'm going to put negative 4 and negative 1 on the number line. Make sure you're careful with your negatives. Negative 4 goes to the left of negative 1. And I'm going to remind myself right now which of these should be open or closed circles. Since this does have an equal sign, I'm going to put a closed circle on the number I got from the top, which was the negative 1. But I'm going to put an open circle from anything that came from the bottom because that would make the function undefined, right? It wouldn't make it 0. It would make it undefined because that's the bottom. So I have 1, 2, 3 sections to test. If I plugged in something like negative 5, and we could factor this to make it a little easier, but I'll just leave it. Okay, if I plug in negative 5, this would be negative 3 plus 15, so that would be positive, but the bottom would be negative. If I plugged in, I can't plug in my 0 here, so be careful. Don't get in the habit of always putting 0 in for the middle section because 0 is not in between these two. So I'm going to need to put in something like negative 2. So if I plugged in negative 2, the top would become positive, and so would the bottom. And then now I could use 0 for this section. So if I plug in 0, I would get a negative on top and a positive on the bottom, so negative. So I want to know where I'm greater than or equal to 0, so that's that middle section, but parenthesis for the negative 4 because it came from the bottom, bracket the negative 1 because it came from the top. All right, again, let me know if you need more help with the factoring or any of the steps that I kind of went quickly on just to make sure I got to the new material without taking too long. And good luck.